Hello students, in previous lecture we have studied about the polynomials. That is, polynomials are of different types, and those types of polynomials which is depends upon different factors. That is, for example, monomial, binomial and trinomial. These are the different types of polynomial which is based on number of terms present in it, as well as there are linear polynomials, quadratic polynomials and cubic polynomials, which are also depends upon the degree of that polynomial. Then we have already studied about the polynomials. That is, polynomials should be written in its standard form. Then how many forms we can write the polynomials? See here, polynomials we can be write into three different forms. That is, first, standard form of the polynomial. Second, that is index form of polynomial, as well as coefficient form of polynomial. Coefficient form of polynomials. Then let us consider one of the polynomial in x variable. For example, here if there is a polynomial that is 5x square minus 7x plus 3x raised to 4 plus 9. That is one of the polynomial which is given here. Then we can write this polynomial in three different forms. See here, the first, standard form. Then while writing in its standard form, we have to arrange those terms in the polynomial according to their descending order of the degrees or power of the variables present in that terms in the polynomial, or it should be written in the ascending order of the degrees of those variables in the terms of given polynomial. Then first of all we have to write that polynomial in its standard form. Then see here, let us write that polynomial in that standard form, that is px is equals to, see here, the term with highest degree of its variable, that is 3x raised to 4. Therefore first of all we have to write it 3x raised to 4. Then there is one more term, that is 5x square, but here the term with degree 3 is absent, isn't it? Then see here, we have to write then the term in which the degree of that variable is 2. We have to write first. Therefore see here, plus 5x square. Then one more term, that is minus 7x, of which degree is 1. Therefore we have to write minus 7x raised to 1, or minus 7x plus 9. At last we have to write constant term. That is the standard form of the given polynomial. Or we can write the same term in the ascending order of the degrees of variables in each term in the given polynomial. Therefore 9 minus 7x plus 5x square plus 3x raised to 4. That is also standard form of that polynomial. But generally we write the standard form like this, or in the descending order of the degrees of variables in each term of given polynomial. Then the same polynomial we can write in its index form. Index form, see here, the standard form in which the degree of x variable is absent. See here, here 4 is there, 3, that means cubic term is absent there, 2 is there, that means quadratic term is there, minus 7x raised to 1, that is here, linear term is there, also constant term is there. Then we have to convert it into index form. To convert it into index form, we have to write, see here, 3x raised to 4. Here cubic term is absent, therefore we have to write 0x cube. Then plus 5x square minus 7x raised to 1 plus 9x raised to 0. Then see here, all terms with degrees are there in descending order. See here, the degree of that x is 4, 3, 2, 1 and 0. That is the index form of given polynomial. Then we can write the coefficient form of that given polynomial. But when we write the coefficient form of any given polynomial, first we have to convert it into its standard form, then we have to write it in its index form, then and then only we can write the coefficient form. We can't write the coefficient form of that polynomial using only the given polynomial. Therefore, first of all, that polynomial is converted or written in the standard form, then it is written in its index form, then we can write the coefficient form of that polynomial. Then see here, only coefficients are written in the bracket using comma or separating those coefficient by comma. That is the coefficient form of that polynomial. Therefore, see here, the coefficient of that first term is 3, 0. Second term, coefficient of second term is 0. Coefficient of third term is plus 5. Coefficient of next term is minus 7. See here, we have to write the coefficient with its sign. Then plus 9. That is the coefficient form of given polynomial. Then we will solve the examples from 3.1, which is based on these concept. Then see here, we will convert the different forms of polynomial into each other. That means we can convert coefficient form into index form as well as standard form, as well as the standard form or index form into coefficient form. Or any polynomial, if it is given in index form, then we can write it into its standard form as well as in coefficient form. Let us solve one of the example which is based on those conversions. Then example which is given here in the coefficient form, that is, see here, 3, 0, minus 7, 0, 0, 9. That is the coefficient form of given polynomial is here. Then see here, first of all, we have to count total number of coefficient. See here, total 1, 2, 3, 4, 5, 6. 6 coefficients are given here. Therefore, highest degree of given polynomial, that is here 6 minus 1, that is 5. Therefore, the here coefficient of first term is given here. Therefore, let us write the polynomial in index form as well as in standard form using those coefficients and using this degree in any variable, that you may take x variable or y variable or a, b, c, d variable. Therefore, here in polynomial in a variable, then we have to write here, that is 3a raised to 5 because degree of that polynomial is 5 plus 0 is given here, therefore 0 a raised to 4. Then minus 7 coefficient is given here, therefore minus 7 a raised to 3 or a cube. Then 0 is given here, therefore 0 a square. Again 0 is given, therefore 0 a raised to 1 plus here 9 is given here, therefore 9 a raised to 0. Then see here, indices of the terms are written in the descending order, that is 5, 4, 3, 2, 1, 0. Then that is the index form of the polynomial. Then we can write the same polynomial in standard form. Therefore, we have to write the standard form of that polynomial, avoiding to write the terms of which coefficient is 0. Therefore, we have to write, see here, 3a raised to 5. Then we should not write this term. Then minus 7a cube. Then we have to avoid to write those two terms again. Plus 9a raised to 0 means 9, that is the constant term. Therefore, again we have to write this 3a raised to 5 minus 7a cube plus 9. Then that is the standard form of polynomial. That means we can convert coefficient form into index form and index form into standard form, as well as if the standard form is given of polynomial, then we can convert it into index form as well as in the coefficient form. That type of examples we will solve from practice set 3.1. Then see here, we will solve few examples from practice set 3.1. Then see here, question number 1 from practice set 3.1. Here the question is given that state whether the given algebraic expression is polynomial or not. Then one of the example is given here, that is 2 minus here 5 root x. See here, by observing this the terms of those polynomials, then we can convert it into standard form. Or see here, 2 minus 5 root x is there. Root x means we can write this like this, 2x raised to 0, because here that is the constant term, minus 5. Here root x means we can write it like this, that is x raised to here 1/2. That means here the index of x is 1/2, and the definition of polynomial, in which the polynomials are those algebraic expressions that variables of which index should be whole number. That means the index of the variables should be positive integers or 0. That means it is a whole number. But here the index of this x variable is 1/2. That is not a positive integer, it is a fraction. Therefore, it is not a 2 minus 5 root x is not a polynomial. It is not a polynomial. Then see here, one more example is given here, 10. Then see here, 10 is a constant term. Therefore, that can be written like this, 10x raised to 0. That means let us write the polynomial in x variable, that is 10x raised to 0. Therefore, here the degree of that x is 0, and here the coefficient is 10, that is a real number. Therefore, it is a monomial type of polynomial. It is a monomial, and therefore 10 is a polynomial. It is a polynomial. As well as one more example is given here, that is y plus 1 upon y. All of you have studied the rules of index or indices. That is here y raised to 1 is there, or here 1 y raised to 1 plus here 1 upon y is there. That means 1 upon y raised to 1 is there. Then we have to taken that y into numerator. Here y is in denominator. Therefore 1 y raised to 1, let us p polynomial in y variable 1 y raised to 1 plus 1 y raised to minus 1. When that y is taken in the numerator, that in according to the rule of indices, that plus 1 index or degree, it's converted into minus 1. And here the degree of that second term is minus 1. Therefore here y plus 1 upon y is not a polynomial. It is not a polynomial. That is about the examples from question number 1. Then we will solve few examples from question number 2, question number 3, as well as from question number 4. Then question number 2, in which question is given, that is write the coefficient of m cube in the given polynomial. Then the first example which is given here, only m cube is given here. Therefore here that m cube can be written in 1 m cube. Therefore let us consider polynomial in m variable, that is 1 m cube. Therefore here coefficient is 1. As well as one more example is given here, that is, see here, minus 3 upon 2m minus root 3 m cube. See here, only we have to write the coefficient of m cube. Therefore see here, the coefficient of m cube is minus root 3. Then one more example here given, you have to solve that example from it. Then question number 3, in which examples are given here, that is, there are few informations about the polynomials are given there, and then we have to write the polynomials according to those concepts. Then see here, first we have to write trinomial with a degree 8. Then see here, trinomials means there are 3 terms should be there, and degree of that polynomial should be 8. Therefore highest degree of variable is 8. Then we have to write, let us consider the polynomial in m variable, and here the degree of that polynomial is 8. Therefore we should write the degree of that m is 8. Therefore here suppose minus 2 m raised to 8, then there should be only three terms should be there. Therefore here we can write any polynomial with degree 8 of that m variable, then plus 7m raised to 5 plus 9. That is the trinomial, or any one of the polynomial you should write, that is here 5m raised to 8 minus 7m cube plus 2m square. That is also polynomial, that is trinomial with degree 8. Like that you can write any polynomial of your own imagination. that is one more, that is monomial with degree. Monomial with degree 7. Then see here, monomials means which contains only one term. Let us consider polynomial in y variable and degree of that polynomial should be 7. Therefore, here we can write minus 12y raised to 7, 1y raised to 7, 2 upon 3 y raised to 7, root 5y raised to 7 are the few examples of monomial with degree 7. Then in question number 4, we have to identify the degree of given polynomials. In the question number 4, the examples are given here. Then we have to identify the degree of those given polynomial. Then see here, first example, that is root 5, which is given here. Then we have to convert this into root 5 x raised to 0. Here constant term is given. Therefore, here the degree of that given polynomial is 0. One more example which is given here. See here, that is we have to find out the degree of that polynomial. 2p minus root 7. Then see here, only here two terms are there in which the degree of that first term, that is 2p raised to 1, minus root 7, that is the constant term, therefore that is written in the form of root 7 p raised to 0. Therefore here degree of given polynomial or above polynomial is highest degree, that is 1. As well as we can write the degrees of few more examples, that is given here. m cube n raised to 7 minus 3m raised to 5n, then plus mn. Then here the degree of the given polynomial we have to find out. Then see here, the first term of which coefficient is 1, the second term of which coefficient is minus 3, and one more term is there of which coefficient is 1. Then we have to find out the degree of each term. The degree of this term is 3 plus 7, that is 10. Degree of second term, that is 5 plus 1. Here raised to 5 and raised to 1 is there. Therefore here degree of second term is 6, and here degree of third term, that is m raised to 1 as well as n raised to 1, that is 2. Therefore here the highest degree is 10. Therefore degree of given polynomial is 10. That is about the few examples which is given from practice set 3.1. Then we will solve the examples which is given from question number 5 to question number 8 in the next video, as well as the few concept which is related with the polynomial. Till you should solve the remaining examples from practice set 3.1 from question number 1 to question number 4. Thank you.